What rack power densities are supported with direct liquid cooling? Well, good question actually. For now, we start thinking about the direct-to-chip cooling mostly with the really powerful racks. So it's all spiking. All that liquid cooling interest is spiking because of the AI racks. So let's think about the current densities which we have, and let's mention about the maximum one. So for now, the starting point would be 80 kilowatts. We can start lower than this actually. Well, it makes sense. It always makes sense to implement a direct-to-chip cooling system. Once we get more acquainted with it, understand the technology well, we can just start as, let's say, normal technology which will replace air conditioning in the system. But normally we deploy those direct-to-chip cooling systems with the densities starting at 60 kilowatts, 80 kilowatts. That's the starting point. That concerns the H100 GPUs, SXM5 servers, 4U type of servers with the and we can hold 10, 11 of those servers inside of the one rack, and that's the starting point. The current generation, the next gen, or let's say also current gen of AI servers is NVL72, GB200, GB300. Well, at that point we are talking about the densities ranging from 120 kilowatts to 140 kilowatts. That's the range. And through the liquid we can reject approximately 115, 120. So that's the, let's say, general understanding for the NVL72 racks. And the next, well, with the Ruby or Ruby Ultra deployment, one we can think of about the 220, 240 kilowatts per one server. And obviously right now we are working on the 500 kilowatt racks density up to 1 megawatt in the future. But the biggest one which we actually deployed was approximately 220 kilowatts per one rack. So that's the, let's say, current density of direct-to-chip cooling systems.